Question number 5, we have a particle A is projected vertically upwards from a point O with a speed of 80 meters per second. 1 second later, a second particle P with the same mass as A is projected vertically upwards from O with the speed of 100 meters per second. At time t seconds after the first particle is projected, the two particles collide and coalesce to form a particle C. Part A, show that t is equal to 3.5. So t is the time when both of the particles collide. So first we need to draw a diagram that shows the situation. So let's say this is the ground O, point O, from where the two particles are projected. So let's say this is first A, which is projected, and it is projected at a speed of 80. So that means u is equals to 80. The final speed is not given to us yet, and since it is operating against the motion of gravity, the acceleration will be minus 10. And as for particle B, it is projected a second later. So let's say this is particle B, and then it is projected upward with a speed of 100. And like A, it is working against gravity, so acceleration will be minus 10. So what we can notice is that when both particle A and particle B will collide, they both will cover the same distance, since they are both projected from the same horizontal ground, which is point O. So we need to create two equations that show this. The kinematics formula, which is displacement or distance is equal to ut plus half at square. Now in this equation, t will be the time t, which is the time which they collide, and which will also be equal to the time that they both cover the same distance. So for particle A, the initial speed was 80, so this will be 80t plus half times minus 10 t squared. So this will simplify to 80t minus 5t squared. For particle B, we can write it as the initial speed was 100, so this will be 100. B was projected 1 second later than A. That means that it will take t minus 1 seconds for it to cover the same distance. So this will be 100t minus 1 plus half, and the acceleration was again minus 10, and this will be t minus 1 squared. So if I could simplify it any further, I would write it as 100t minus 100 minus 5t minus 1 squared. Now we will equate these two equations or formulas. So this will become 80t minus 5t squared is equals to 100t minus 100 minus 5 times t minus 1 whole squared. It will become 80t minus 5t squared is equals to 100t minus 100 minus 5. When we open t minus 1 whole squared, we get 2 squared plus 1 minus 2t. So this becomes 80t minus 5t squared is equals to 100t minus 100 minus 5t squared minus 5 plus 10t. Now this minus 5t squared and this minus 5t squared cancel, and putting all like terms together, we get 80t minus 100t. This goes on this side, as well as this minus 10t. This becomes minus 10t equals to minus 100 minus 5. Minus 30t is equals to minus 105. Divide minus 30 on both sides. We get t is equals to 3.5. For part B, find the height above O at which the particles collide. Both of the particles cover the same distance when they collide, since they both start from the same point O. So we just need to substitute this value of t into any of these two distance formulas, either of A or for B. So since A is more simplified, we will use that. So we said that the displacement of A, or the distance traveled by A, was 80 t minus 5t squared, and substituting this value of t, we can get 80 times 3.5 minus 5 times 3.5 squared, and we get 218.75 meters. This is the height above O at which the particles collide. So for part C, we need to find out the time from A being projected until C returns to O. So that means that we have to map out the entire journey of A from the time of projection till it comes down to the ground as particle C, since particle in A and B collided and became one particle C. In part A, we found out that the time of collision was 3.5 seconds, and that was t. Now for particle A, this t was 3.5 seconds, whereas for particle B, this was t minus 1. That means it was 3.5 minus 1. So it took particle B 2.5. But since they're asking about only particle A in this question, we will take 3.5 as the time it took from projection till collision. So this is point O, and now let's say that this is particle C. In part B, we found out the height of both the particles when they collided. That was 218.75. Now the question is that does particle C now keep moving upward, or after collision does it move back towards the horizontal ground O? Now for that we will use the conservation of momentum. So after they collide and become particle C, we can say that the mass was 2m, m being the mass of both particle A and B, and this v will become the final velocity after collision. So now we need to find out the initial speeds of both particle A and B before collision. For that we can use the v is equals to u plus at formula. So for A, this will become, initial speed was 80 and the acceleration was minus 10, and t in this case was 3.5, and that is equals to 45 meters per second. As for B, the initial velocity was 100 minus, and the acceleration was 10, and time was 2.5, and this becomes 75. These two are the initial velocities of A and B directly before collision. So we can insert these here. So this will become 45m plus 75m is equals to 2m times the final velocity of C. So 45 plus 75 is 120 m, and this is 2m. Dividing 2m on both sides, the m's cancel out. This becomes 60 is equals to the velocity of C after collision. So what that means is that directly after collision, particle C moves upwards, and then again the acceleration is minus 10 since it is moving against gravity. But now we need to find out the maximum height that particle C reaches before it starts moving downwards, and that will be when its final velocity is 0. We can use the kinematics formula, which is final velocity squared minus initial velocity squared is equal to 2 times the acceleration multiplied by the distance traveled. The final velocity will take as 0 and the initial as 60, which we found out here. 60 squared is equal to 2 minus 10 nx. So this becomes minus 3600 is equals to minus 20x, and if we divide minus 20 on both sides, we get x is equals to 180 meters. That means that C travels a further 180 meters above this 218.75. First, let's find the time that it took for particle C after collision till the point it reaches its maximum height. And for that, we can use the v is equals to u plus at formula. So we can take the final velocity as 0, since that was when it reaches its maximum height, initial velocity as 60, which was its velocity after collision, and the acceleration will be minus 10 again, since it is moving against gravity, and this is t. So 60 is equals to 10t, that means t is equals to 6. So now we know that it took particle A 3.5 seconds to go from projection to the point of collision. Then it took another 6 seconds to go from the point of collision to its maximum height. The final thing we have to do is to find the time that it takes from going from its maximum height to point O again. And for that, we can now use this 180 meters which we found out. So C is now at its maximum height. So during collision, it traveled 218.75 meters. Then it traveled a further 180 meters. That means now it is at a height of 398.75 meters, is equals to ut plus half at squared formula. So x is 398.75. It starts from the top when its velocity is 0, so this entire thing becomes 0. And since it is moving downwards, now its acceleration is 10. And this becomes t squared. 398.75 is equals to 5t squared. Dividing 5 on both sides and then taking the square on both sides, we get t is equals to 8.93 seconds. Now all we have to do is add all the time periods that we have found. So the first 3.5 seconds for A from projection till the point of collision, then another 6 seconds to reach its maximum height, then the time it took to go from its maximum height to the point O again, which is 8.93, and that gives us the final answer of 18.4 seconds.